Welcome to solverfy.
This is the answer to chapter 15, problem number 82 from the Smith Organic Chemistry textbook. And this problem is asking us to draw a mechanism for the use of trialkyl reagent with a radical initiator to reduce this alkene to a couple different alkanes, or we're also told the product could just be the replacement of the bromine with a hydrogen. And so basically, this is just your standard free radical reaction like we've been talking about in this entire chapter. So the initiation step is this Z molecule with the free radical on it is going to steal a hydrogen from the trialkyl tin, and this is going to give us a tin radical species. And so that radical tin species is then going to take the bromine from this starting material by way of the carbon bromine bond cleaving. One of the electrons going to form a bromine tin bond with the free radical on the tin, and then the other electron from the carbon bromine bond reverting to the carbon. So we now have this carbon free radical. Oops, I misdrew something. Sorry. So this, I drew an H. Why isn't this working? I apologize. My eraser function does not appear to be working. Okay, there we go. So this, I drew an H, and of course, this should be a bromine. So let me fix that quickly. There we are. Okay, so as I was saying, we have this free radical carbon species here, and we have our trialkyl tin bromide. And then this free radical species can do one of three things. So the free radical can attack the closer of the two carbons involved in the alkene, in which case you get a 5-membered ring with a methyl group. The radical ends up on the methyl group, and then from another equivalent of this starting trialkyl tin hydride, we can take the hydrogen, and so that will regenerate our free radical tin species, and it will give us this first product that we're told we can form. Alternatively, the free radical could attack the far carbon, which will make a 6-membered ring with the free radical on one of the carbons in the ring, and they're all equivalent here, so it doesn't matter which one you draw it on. And then that can take the hydrogen from another of this starting tin species. And then that's going to give us the 6-membered ring product and regenerate our tin radical. Or lastly, the free radical carbon species could just directly take a hydrogen from the starting tin species and just end up as this alkene, uncyclized, and the third product that we're told that we form. And then again, I failed to draw it here, but this would also result in reforming our tin radical so that it can continue reacting and continue propagating the reaction. And so any of those three results are possible. That's how we get a mixture of these 4 products that we're told that will form. And that is the answer to chapter 15, problem number 82.